So we're going to start off today with using the calculator and rational inequalities, okay? But we're going to start with something we know, something we understand. So look at this. Look at this function. Consider this function. So let's set up and solve an equation for when this function equals 4. So if we have 2 over x minus 1 equals 4, how would we solve this equation? Think about yesterday. First we found the restrictions, and then we found the least common denominator. What is the least common denominator in this case? X minus 1. So we're going to multiply both sides. Here's the equation again. X minus 1 equals 4. We're going to multiply both sides by, what did you say it was called? Least common denominator. Very good. And the least common denominator in this case is x minus 1, just like you said. Okay? What happens on this side when we multiply by the least common denominator? This cancels. Good. And we're left with 2. And what happens on this side? Just poof, it turns into 4x minus 4? Correct. Good. You know what, I'm just teasing you about that. It's okay. Okay? So add the opposite to both sides. What does that mean? Add the opposite? It just means solve the equation, right? We just add 4. So 6 equals 4x. And we divide both sides by 4. X equals what? 6 over 4. Is it okay if I put 1.5? Is it okay if I put 6 over 4? Not as okay as if I put 3 over 2, right? 3 over 2 is better because it's simplified. Absolutely. Okay? So this is something you're familiar with, right? This is what we worked on yesterday. Okay? How is this different? Right, it is an inequality and not an equation. Okay? So what do you think changes? You think everything changes? You think nothing changes? Something is obviously going to change because it's an inequality and not an equation, right? Normally when we go from equation, like graphing, if we graph an equation compared to graphing an inequality, when we graph an inequality we shade, right? We shade. So there's more solutions than just one. Do you think that's going to be similar in this problem? Yeah, okay. So the steps to solving the inequality are the same. Dun dun dun. Okay? So guess what that means goes right here. 2 over x minus 1. Very good. So if this is 2 over x minus 1 equals, or is greater than or equal to 4, guess what I multiply both sides by? X minus 1, which is the least common denominator. And then that means that cancels with that, so we have 2 is greater than or equal to 4x minus 4, right? Okay, which means then I add 4 to both sides and get 6 is greater than or equal to 4x. And then I divide both sides by 4 and get x is greater than or equal to 1.5, or x is less than or equal to 1.5. Because I said it wrong just a second ago. What I meant to say was 1.5 is greater than or equal to x. Are these two the same thing? Do you see that? You know that for real? Good. I'm proud of you for that. Okay? However, in the case of the rational function, this solution is no, it's not. Look at the table. Let's look at the table to see why. Okay? So in our calculator, I need a better. Where's my? Okay, sorry about that. Pardon? We'll get there in just a second. Okay? So I want a fraction, so I'm going to use control divide to get myself a fraction. And I have 2 over x minus 1. Well, I still have another equation in there. What's up with that? I don't like that. Okay, there, that's better. Now let's look at the table. Okay, so Control T. So first of all, what's wrong with my table compared with the one that we're given? It's not with the 0.5. Do you remember how to do that? I showed you last week. Menu, table. Yep, edit table settings. Where do I want it to start? 0. How do I want it to count? By 0.5. Okay? So I've got 0 at -2. When x is 0.5, y is -4. When x is 1, y is #u. Oh, undefined. Okay. X is 1.5, y is 4. X is 2, y is 2. X is 2.5. Is it okay if I put 1 1/3? Do you know those are the same? Good. And then 1. Okay. So, on the table, we're going to circle the entries where x is less than or equal to 1.5. Where is x less than or equal to 1.5? Like all these values right here, right? Now, I didn't close my circle. I guess I could because it's the top of my table, but I know it goes on, right? Okay. On this table, shade the entries where the value of the function, where f is greater than or equal to 4. Only right there, right? Do those sections match up? They're not the same, are they? Only one value is the same. That's not good. That shouldn't happen, should it? Okay. No need to worry, though. I can tell some of you are worried. I think some of you come into this class worried, but that's a different story. In the previous example, the algebraic solution to the inequality did not seem to agree with the tabular solution. What does that mean? With the table, right? The algebraic solution didn't match the table. Well, we want to know why. A better table may provide more information. So we actually need to go into our table. We still have the same values in there, right? But let's go into the table. Menu, table. And let's make our table look more like this. So we have to edit our table settings again. We still want to start around 1. We can always adjust it if we need to, but how do we want our table to count? By 0.1. Okay? So 0.8 is -10. 0.9 is -20. 1 is an error. What's 1.1? 20. What's 1.2? 1.3? 6 2/3? 1.4? 5, and then 1.5 is 4, and 1.6 is 3 1/3. Okay? Now, let's circle where the entries are less than or equal to 1.5. So like right there, right? Okay, I did that. And let's shade where the value of the function is greater than or equal to 4. Isn't it all that right there? Where do these sections match up? Between x is equal to 1.5 and x is equal to 1, right? Isn't it between those two values? It doesn't include x equals 1, does it? Because that's an error. That's an asymptote. Oh, sorry. By the way, what happens at x equals 1? asymptote. So the actual solution to the inequality, does this look familiar, guys? X is less than or equal to 1.5. Isn't that what I got over here? So that's partly right, right? It makes it sound like it's not right at all, but it's not all the way right. How about that? Okay, it's not the whole answer. Everything less than or equal to 1.5 and everything greater than what? 1, absolutely. And why is it 1? Because that's where the asymptote is. Very good. Okay, so let's look at this graph right here with a point A and a point B. Okay, let's start just by looking at point A. The equation f of x equals 1 has a solution at x equals 3. Okay, over which intervals is the value of this function, the y values, greater than or equal to 1? So if we're talking about the y values, those are the y values, where is this function greater than or equal to 1? Isn't it like right here? Do you see that that is the only part of this function that's greater than a y value of 1? Greater than or equal, I guess. Does that make sense? So tell me, now what are the x values for the blue part that I just shaded in? Now look this way. What are the x values? So it's less than or equal to 3 and greater than 1. See? Because that's where the asymptote stops it. Does that make sense? Okay, so where, over what intervals is the value that the y values less than or equal to 1? So there's my line again. Where is it less than or equal to 1? Do you see that it's right here and all this part over here? So how would we write that? Which x values? X is greater than 3? Greater than or equal to 3, because the point lies on that line, right? And less than what? Where's the asymptote? 1. Okay? Now, guys, I know all of you don't need the color, but some of you do, and that's why I'm using it. If you want to use the color, come borrow some colored pencils. You know that's okay. All right? Or some of you have your highlighters out and stuff. That's good. Okay? Any questions about that? Okay, so look here. This equation again, now it gives you an equation up here. We haven't looked at the actual given formula for that yet, but we haven't really needed to so much. Okay, the equation f of x equals negative 2 has a solution at x equals 0. So this is point B. Okay, when x is 0, y is negative 2, right? So over what intervals is the value of the function greater than negative 2? So y value is greater than negative 2. When is that happening? Can you see that it's here, the orange, and all this up here? Do you see that? What x values are the orange? Comes all the way from here and stops right at the point. How do we say that? Less than 0, right? X is less than 0. Because see how it's asking me a different question this time? It was asking me where is it when the function is greater than or equal to 1. Now it's saying when is it greater than negative 2. So that affects my sign here as well. Okay? And where else is it? What other x values is it? X is greater than 1. Now it says show symbolically and on a number line. Do you understand that this is symbolically? So what's my number line look like? Here's 0, here's 1. If it's got to be less than 0 and greater than 1. Remember when we did these a couple weeks ago? Done. So the last one. Over what intervals is the value of the function, so the y value, where's the y value, less than or equal, did I just do it backwards? Oh no, I did. Okay. Less than or equal to -2. Just right here, right? This pinkish purplish color, I don't even know if you can tell that what color that is. So what are the x values where that's true? X is greater than 0 and less than 1. Oh, I wrote that backwards. Sorry about that. Like that. So on a number line, it's greater than 0 and less than 1. So it's just everything in between them, right? How are you feeling about this? You seem awfully quiet. That's why I'm asking. Are we just thinking about other stuff today? That's okay. So here's the graph. Okay? It gives you the equation. Set up and solve an equation to locate the vertical asymptote of this function. How do we find a vertical asymptote? Oh my gosh. You just made my day. Let's set the denominator equal to 0. 2x minus 3 equals 0. Add 3, 2x equals 3. Divide both sides by 2, x equals what? 3/2? Does that help me graph anything, or do I need to go to the decimal? 1.5 makes more sense to me on a graph, doesn't it? Okay, so you remember yesterday how I told you you would know when if I wanted a decimal or a fraction, and it would just depend on the situation? Does this make a little bit more sense knowing this situation? Good. Okay. So we need to draw on our asymptote. That's going to help us a lot. It's crossing the x-axis at 1.5, right? Okay. Okay, we got that? Point A has a coordinate of -3, an x-coordinate, right? X-coordinate of -3. Evaluate the function to find the y-coordinate. Oh, what does that mean? If we know x, how do we find y? Oh my gosh, we plug it in. Okay, so 4 times -3 plus 1 over 2 times -3 minus 3. What is 4 times -3? -12 plus 1? -11. 2 times -3? Minus 3? -9? Equals? (1.2) repeating. Okay, so this point right here, x-coordinate is -3, y-coordinate is 1.2 repeating. Okay. Point B has a y-coordinate, a y-coordinate this time, of 1.5. Set up and solve an equation to find its x-coordinate. What's that going to look like? 4x plus 1 over 2x minus 3 equals 5.5, right? Now this is a whole lot like this problem right here on the previous page, isn't it? Okay, so we got that. Multiply both sides by 2x minus 3. That cancels. We have 4x minus, or plus 1, excuse me, equals 5.5 times 2x. That's 11x. And 5.5 times negative 3. Thank you. So if we want to solve this equation, let's subtract 4x from both sides, and let's add 17.5 to both sides. So I get 18.5. Oh, thank you. I'm already doing the math in my head, aren't I? Sorry about that. So this is, thank you, this is 17.5 equals 7x. Divide both sides by 7. X equals what? 2.5. So this point right up here, point B, the x coordinate, which I just found, is 2.5, and the y coordinate is 5.5. Okay so far? Now we're about to break the colors out. What's the interval over which this function, the y values, are greater than 5.5? Over which interval, like between two numbers, that's like on this page right here, these are the intervals, okay? Over which interval is this function greater than 5.5? So where is y 5.5? Above b, right? There's where y is 5.5. So where's the function greater than 5.5? Just right there, right on the green part, right here. So what are the x values of that green part? It's less than 2.5. because it's that way from 2.5. But what is it that way from? The asymptote, right? 1.5. Yes? On my number line, there's 1.5, there's 2.5. It's greater than 1.5 and less than 2.5, so it's right in the middle, isn't it? Don't be jealous of my graph. I know it's beautiful. So where, over which interval is the value of this function, the y value, less than or equal to 5.5? Well, I've got my yellow line up there to tell me where 5.5 is, right? So that means everything below that line, all this orange stuff, is where it's less than or equal to 5.5, right? So what intervals are those? X is greater than, greater than or equal to, you think so? Yeah, absolutely, right? 2.5, because that's the x value right here, remember? Where that starts. And x is also less than what? Now, here is a tough question. I want you to just think about it for a second. Don't anybody shout out an answer. I just want you to think. Is this sign correct? Or should it be x is less than or equal to 1.5? Okay, now that you've had a chance to think, somebody answer for me. Excellent. It can't be equal to because that's where the asymptote is. Very, very good. Okay? How are we feeling on this? Pretty confident? Okay? So you have 6, 7, 8, 9, 10, 11, 12, 13, and 14 to do. Okay? We do still have some time in class, so why don't you continue working on these? Ask me questions as you go. Ask each other questions as you go. Okay?